today's class will be covering the topic specialized process models. Now, what are specialized process models? These specialized process models, they are going to take many features of one or more conventional models. Now, what are these conventional models? These conventional models are the previous models that were already developed. Now, the models that we have studied till date is waterfall model, incremental model, spiral model. We have studied different types of models. So these specialized process models, they are going to take many of the features from these many models, like some of the features that were the best, and they've combined into these models, and these model is called as the specialized process model. Now these model that is the specialized process models are used when a narrowly defined software engineering approach is chosen. Now, suppose a narrowly defined software engineering approach means you need to focus on some specific category only. You need to reduce the cost. So when you need to reduce the cost, you're going to make use of components like reusable components. So in such type of approach, you might use one type of model, that is a component-based development. Or if you're going for, if you're focusing on the performance, the availability, the load time that it can handle, then you go for another type of model. Now we'll see what are the different models that are present within the software between the specialized process model. Now there are three types of specialized models. The first one is component-based development, formal methods model, and the aspect-oriented development model. The first one is component-based development. Now this model, as the name comes, component-based development means you're going to take components that were already built, pre-built components, or we can say that ready-to-use components. You're going to take these ready-to-use components and you're going to embed it within the software. You're going to build the software by making use of these. Now this component-based development is taking many of the characteristics of the spiral model. As for the definition for spiral, for specialized model, we have seen that it is going to take many features of different conventional models. So this component based model, it is going to take feature of the spiral model, and it is going to follow an iterative approach. Now what is an iterative approach? That it is going to keep on continuing the cycle until the entire software is complete. Like suppose you're following the first step, then the second, then the third. Now these will be followed until the entire software is being developed. Now these models focuses on pre-packaged software components. Now like pre-packaged software components, suppose you can use different libraries are available, different packages are available. So you can make use of those predefined pre-built packages and you can embed it within your software and you can use. Now this component-based development, it promotes software reusability, because in here these are ready to use components. You can make use of these components and make a new software, and if suppose the software is no longer required, you might again take this component from this particular software and you can embed it into a new software. That is why it promotes software reusability. The next is commercial off the shelf. That is also called as COTS. Now this commercial off the shelf, this means ready to use software. As I told you, you're going to make use of ready to use components. Now these ready to use components, these are developed by multiple vendors and they are going to sell this particular software. Now these different components can be used to build a particular software. Now these components that are there within the software, they are going to have some specific functionality that has got well-defined interface. That is, everything is ready. You're going to have a well-defined interface and you can directly use this components. You can integrate them into your software. Take the components that are well-defined and has got specific functionality and embed it within your software. You're going to put this within your software. Now suppose we take an example. If suppose you've got a computer, you want to change it into a gaming PC. So what do you do first? You're going to identify what is the system configuration, what is the CPU, RAM, graphic cards, hard drives. You're going to take the configurations of all of the things. Now why do we take these configurations? So that you can determine that the system will be able to run or not. You have a particular computer. You need to change it into your gaming PC. So first thing is you're going to determine the different configuration settings. Now, after you determine the different configuration settings, what is the next thing? You're going to determine the storage, how much storage is required. Then you need to focus upon the GPU, the graphical processing unit, for improved graphics. Then the motherboard, the different hardware, all of the things you're going to focus. Now in here, for the storage, you might require a lot of RAM. You might, now in here, you want to update your previous system into a gaming system. What you're going to do? You're going to update the storage into your specified RAM. You might take 1 TB, 2 TB, 500 GB of RAM can be taken for storage. Then you might upgrade your graphic card, or you might optimize your graphic card for better performance, like overclock the GPU. Then what you're going to do, you're going to check the motherboard, the different hardware, if you require another hard drive, you're going to take all of this and you're going to assemble all of them together. The cooling units, the power units, everything will be assembled. After assembling each of them, as you're converting into the gaming PC, you might have to kill some unnecessary processes that are not required for gaming. Within the task manager, you're going to go and remove all of them, and your system will be updated into the gaming PC. So not in detail, but the main thing what you're doing is you're going to pick this RAM from the market, whatever is available, what is your choice, what is the compatibility of your system. Based upon the compatibility, you are going to pick a graphic card unit. You're not going to sit there and you're not going to make another graphic card. You're going to just go fetch it and you're going to integrate that within your PC. So making these slight changes, you're making a completely new system. The next slide focuses on the different steps that need to be followed for developing a component-based development model. Now, in this component-based development model, the first step is you're going to focus on the available component-based products that are there within the market. You're going to research one of them. Because you're going to have multiple companies are going to be there that are going to make a particular RAM or a graphic card. You've got different models. So you're going to identify what are the different companies. You're going to research what are the different functionalities each and every product is going to provide you, and what are going to fit within the application domain that you are going to develop. That is the first step. The next step is component integration issues are considered. Now within this component integration issues, now suppose you are developing a particular system. Now this particular system has got, like, suppose 3 different components are there. You're going to have first, second, 3 components. These 3 components need to be embedded within a software. Now if suppose these 2 components are based on Windows and the third component is based upon Linux. So in here, if you embed this first and second Windows based application, there's not going to be any issue within the software. But this third application, this is based upon Linux. So in here, how many issues are going to arise when you are going to embed this Linux based component within the software? Because it is going to be very difficult, because one particular system is going to completely focus on Windows or in Linux. Or you can completely change the system into a guest software, like it is going to complete as a guest, it is going to work as a guest operating system. You might have another operating system involved where you can completely switch into Linux. But in here, you've got 3 different components that are focusing on different operating systems. So in here, an issue arises while you embed the third software. So you're going to identify if there are any component integration issues. Now, when you identify if any issue is there, what you are going to do, you're going to resolve this issue by changing this particular third component into a Windows-based component. Then the next one is a software architecture is designed to accommodate the components. It is like you're going to make a plan before you're going to design. Like before you're constructing a house, you make a particular plan. The same way you're going to make an architecture before you're going to accommodate all of the components within the software. You're making an architecture, what are going to be the different, where you're going to give the input, what is going to be the output, what particular component is going to perform the processing part. That is going to be identified within the architecture. Within basic electronics, you're going to have different architecture diagrams for a particular architecture, PN junction diodes, where you're going to assemble this, where you're going to ground this particular architecture. Every points are focused. The same way within the software architecture also, you need to design an architecture. The fourth point is components are integrated into the architecture. Now, as you've made the architecture, you know what is the plan, which particular component needs to be connected by which cable and where. So you're going to integrate all of these components within the software. The fifth point is comprehensive testing is conducted to ensure proper functionality. Now, this term comprehensive in here means altogether. Now, as we are using different components, so in here, this particular component individually, it is being tested. Second component is individually tested. Third component is individually tested. That gives you perfect result. But when you're integrating all of this together into one particular software, 1, 2, and 3 are there one within the software, you're going to do this complete testing as a whole. That when these 3 components are there within one software and they are working all together, will it form any errors, any bugs are going to occur or not? That is comprehensive testing. If any type of error is being formed, then you're going to again make the changes, and then you're going to again make, if any changes are there within the architecture, you might follow this 5 steps again to ensure all of this are correct. These are the steps that need to be followed for component based development. Now, there are few disadvantages of component based development. The first one is component certification. Now, there are few majority of the components that you get in the market today are certified, but if suppose a component does not have a particular certificate, then it becomes very difficult for you to trust the particular software. You're going to put a whole lot of money and then it is not going to work, so it might be a waste of resources and time. So that might be our disadvantage. The next is requirement trade-off. Now, trade-off in here actually means the balance. Now, as we have considered that different models are there, or different companies are selling the same particular product. Different brandings are there. So in here, how you're going to identify that, how you're going to analyze the features of one component and another. Now, there is suppose company 1 and there is company 2. They are making the same product. How you're going to identify which one is the best quality or which one provides you more add-on features? That might be a disadvantage. Now, in here to remove the second type of disadvantage, you might need to do a whole lot of research upon the different products by testing. The second type of model is called as the formal methods model. Now, by the name it is called as formal method means this is based upon maths. Any type of model that has any involvement of any type of mathematical formula, any type of mathematical derivation, or any type of mathematical notation, that is called as your formal methods model. Now, why are we using these formal methods model? Because this formal methods model, they are going to enable a software engineer to specify, develop, and verify a computer system by applying rigorous mathematical notations. Now, in here, you might have seen for various phones where you are testing the performance of various phones. What do you use? You use this benchmark testing, right? On what is this benchmark testing based? This benchmark testing is based upon the mathematical formulas or mathematical notation. Based on that exact precise value, you will be able to specify, develop, and verify the different features that are there within your particular software. Now, this formal method model, it is also a basis for software verification. Now, why is this the basis? Because you are able to identify the performance of the particular software that you are developing, how much load it can handle, what are the different specifications that are there. These specifications can be identified by making use of any type of algebraic functions. That is why we're using this formal methods model. This is going to provide you a basic for giving this performance, that it needs to ensure, suppose you're telling that this software gives you 95% of performance. How you're going to prove that it achieves 95% of performance? By making use of a particular formula or a particular notation. If you're focusing on the load, that it can handle 90% of load, how you're going to identify? Based on a particular formula or derivation or a particular notation. This formal methods model is very necessary so that you can completely verify your product, that what you're stating and what you've developed, you've got a match between them. You can verify your software. Now these, whenever you're using these mathematical model, these are used to eliminate multiple problems. Now what are these multiple problems? These multiple problems that can be removed from the particular model is, the first one is ambiguity. Now what is ambiguity? Ambiguity, it can be any type of redundant or duplicate data. You're going to verify if there is any redundant or duplicate data. And now in here, if so, normally if you are unable to identify there is any type of duplicate data, so this formal methods model is going to help you to find any type of duplicate values, any errors, and you can remove them by making use of this formal methods model. Then it is also going to remove incompleteness. Now what is incompleteness? Incompleteness means it is partial. Now if suppose you need to prove that, sorry, what else? Yeah, if you need to prove what is a plus b whole square, it should be a square plus 2ab plus b square. Now in here, it will not be appropriate if you just prove that it is a square plus 2a, or it is a square plus b square. This entire thing you should be able to prove. It should be complete. Incomplete means you're going to avoid any type of partial data. It is going to ensure that the data that you're using, it is complete data should be there. You need to have complete data. This got erased. Now the next one is inconsistency. Now what is inconsistencies? Inconsistencies within your data. In here it means that it keeps on changing. It is not the same every time you run. Now if suppose one time you're going to run the performance, it is giving you some 70%, sometimes it is giving you 50%. So in here, any type of inconsistencies, or this can be based upon your performance or your data should not be inconsistent. It should not keep on changing. So this formal methods model, it is going to remove the ambiguity, the incompleteness and inconsistencies within the data, which might sometimes go undetected. Next is, what are the different problems in formal methods model? Now this formal methods model, it is time consuming and expensive. Now why it is time consuming? Because in here you cannot use the same formula for all the software, or some particular software might not, some specific tools that you're using, that might not work well with some specific formula. You need to derive entire derivation. That is why it is time consuming. And why is it expensive? It is expensive because it requires a lot of training. Now, why do we require this extensive training? Because every software engineer, he might not be good in maths. So in here, he need to identify and learn different mathematical techniques that are used to identify the data and analytics. Then it is difficult to use this model as a communication mechanism for technically unsophisticated people. Now in here, now there might be a scenario where the end user and the developer are there. Okay, end user comes and just tells you that he wants a particular model that has got the highest performance. His requirement is performance. Now this developer, he's a highly skilled person. He has got a hold on this formal methods model. He's a data analyst or a data scientist. So in here, he's got different multiple notations or formulas to prove this performance can be achieved by making use of these and these many techniques. So in here, he cannot make use of the same notations to explain the end user what is being achieved, because this end user has got no prior knowledge of the different mathematical notations that are used. So this model cannot be used for communication between the end user and the developers, because some end users might not have the background knowledge of the different mathematical techniques that are being used within the softwares. And it is also expensive because in here it requires, now as you're doing multiple you're doing multiple CPU runs for the data for this deducing these formulas. It requires more amount of CPU time. It requires more amount of RAM. That is why it is expensive. The third type of model is aspect oriented software development model. That is also called as AOSD model. Now this AOSD model, it is also called as the aspect oriented programming model. Now this model is used because it is a technique that is used to support the programmer in cleanly separating the components and aspects from each other. Now what are these aspects? Aspects are basically the specifications, the different specifications, or you can say the different features. Now there are different components. Some components might have some similar features. So in here, you need to avoid the overlap between these specifications and features. To more clearly understand this, we'll first identify what are aspects. Now, what is an aspect? An aspect is a common feature that's typically scattered across different methods and classes. Now, as you've studied OSD, object-oriented software development, for real-time objects, you're going to create, for real-time examples, you create different objects. Now, whereas within this case, you're going to create different aspects. That is, it is going to combine specific features together so that they do not overlap. Now, what are these different types of aspects? The different types of examples of aspects are, it can be the different designing aspects that are used within the designing phase. Some specific aspects that are there within programming, within maintenance, and economical aspects. The different types of aspects that are there within the, so there are many more, like historical aspects are there, organizational aspects are there. Now in here, these different aspects, now this design aspects, programming aspects, they should not overlap onto one another. Now when this overlap occurs, it can have different bugs to occur within the software, or different errors can be arise within a particular software. Now these aspects are going to encapsulate a concern. Now what is a concern? Now concern can be any type of threat that a developer need to focus on. Something the developer needs to care about, example, a functionality or a quality of service. Now in here, we'll take an example. An example can also be as a security. If we take an example of security. Now consider a MNC. There is a particular company. Now this company has got different levels. In each level, you've got different projects that are being carried on here. Now the top level might have a high-end software development that needs to be very secure. Now the second one might have different types of data that needs to be secure. Then the other might be a financial department. The last might be the cafeteria. And the last one, this area is for the security guard. Now there are different teams that are working in each of the different departments. Each of them are going to have a card that will be used for their access. That is, you're going to have different access cards so that you can enter within the specific areas of the building. Now, if suppose you give the same security card, you're giving the same security card to all the persons within the company. Everyone who walks in, that needs to go within the cafe, the financial department, the data, where the data is stored, and a very secure department where a project is being developed that is not yet shared with the outside world. So in here, if suppose the security key of the security guard gets stolen, he might easily get access into any of the department within a particular MNC. So this might result in the compromise of the security of this entire building. Anyone can take the card of the security guard, or if suppose you just manage to get hands on within the person that is within the cafe while talking. So in here, this results in the compromise of the entire security of the particular software. So in here, you need to make your security cards in such a way that the security guard has got access only to the security area. The security card should be different for the person within the security area. The persons that are working within the cafe, they will be given access only into the cafe area. Even if they want to get access within the financial department, their card won't work in there. Then people working within the financial department should have access to their to their specific department, where the people that are responsible for maintaining and storing the data, they need to get access to that particular department. And the secure department, they need to have a different card. So that is how you're going to make a separation between all this concern. That is called as the separation of concern. Now these separation of concerns is done by modular programming. Now modular programming is, you're going to code in such a way that you're going to code it in different parts. So that coding for one card is only for the security area, then for the cafe, then financial data, then the secure department. You need to code in a modular way, that is called as modular programming. Let's take an example. This is a simple example. If suppose a home needs to be developed, a house is to be developed. Now in here, the different concerns within a particular home to be developed, the first concern can be structure. What is to be the structure of a particular home? What is the lighting plan? What is the pipeline? Now in here, for developing the structure, you're going to develop the structure completely differently. For the lighting plan, you are going to complete a completely different plan. Then for the pipeline, you're going to take a completely different plan. After that, by considering all of these plans, you're going to embed this within the house. That is your complete home. So what you're doing is, you're encapsulating all of these concerns from each other. Because the person that is going to come and design the structure of the home, if you give him this entire integrated house, it will be difficult for him to understand. Or if you give the lighting plan, everything, if you're just giving the same plan to all the people that are going to come and do all of this work, it will be difficult. So you're going to hand over 3 different plans to the 3 different departments of people that are working on the particular house. And in here, the person that has got access to the pipeline plan, he is not going to have access to the light plan. Likewise, for the structure plan, the same way within a particular software that is being developed, different components, different aspects are going to be encapsulated. Now, why are all of these encapsulated? Now, when concerns cut across multiple systems, functions, features, and information, they are referred as cross-cutting concerns. As you've taken the previous example for, you've got the structure, you've got the light plan, and you've got the pipelining plan. Now, the features in here, suppose that there are three different components, and each of them are having functions, features, and information. Each of them might take the information of other. That is called as cross-cutting concern. That might affect the programming and the functionality of one part of the component. That is called as cross-cutting concern. As we've taken the previous example of the security card of the security guard, if he gets access within the financial department, it will be difficult. It is going to compromise. It is going to remove the complete integrity of the organization. That is called as a cross-cutting concern. When a particular concern is going to cut across multiple system functions, features, and information, they are referred as cross-cutting concern. That is going through all of this three. Now, cross-cutting concern is a concern that might affect the whole application, and it should be centralized in one location in a code such as authentication. Authentication for a specific department, it needs to be taken care of. Then how many people are doing the login. Then authentication. Now this authentication is again directly related to the security and transaction management. If the transaction that you're doing is authenticated by a particular person, then securely we need to transfer the funds. So we know what are aspects, what are the different concerns, what are cross-cutting concerns. So in here, as we have studied the aspect-oriented software development technique, it is used to support programmers in cleanly separating the different components and the features from each other. Now, in here, as you're separating the different features and components from each other, it is going to address on these cross-cutting concerns. And how you're going to address this? You're going to address this by identification. First, you're going to identify what are the different cross-cutting concerns. Then you're going to identify how you are going to separate them. The previous example that we have considered. Then representation. Representation, it can be any type of graphical model or any type of prototype can be used for this representation. Composition is how you're going to put all of them together. Now there's an example. In this particular example, you've got the distribution of data, then you've got the security, you've got data management, and you've got the blue ones are the different components. Now these are the different aspects, that is distribution, security, and data management. These are the different aspects that are overlapping upon the different components. Now in here, you're going to make use of different AOSD tools and techniques. Now the different AOSD tools, is one of the example is Aspect J is a tool. Now this J tool, this is for Java. Then you've got as Aspect C++, that is used for C++. Then Aspect XML or Aspect DNG. Now this DNG, it is used for .NET software. Now in here, you're going to make use of tools. These AOSD tools are like Aspect J, C++, Aspect XML, Aspect DNG. These tools are used, and by making use of these tools and techniques, you're going to separate all of these cross-cutting concerns. You're going to encapsulate all the aspects. Now you can see in here, all the components are separately defined. The distribution aspect is completely different. The security is completely different, and data management. All of these are encapsulated. Now in here, why are we doing this encapsulation? Why are we doing this modularization? Now we are doing this because it becomes easy to maintain the software. When you have a clear distinction, a clear picture, if suppose you want to make any change within the security, one type of person, he is given a person might be given a promotion, he needs to be provided with some higher level of security to enter into a specific department. So you need to make changes within this security department. Or if you want to add a particular department in the distribution of data, you can make changes within this particular component in here. So this becomes easy for maintenance. Now, as it becomes easy for maintenance, it is going to reduce the maintenance cost. Now, by making use of this AOSD tools, you can also have like as within the previous model, component based development model, you were reusing the components. In here, you might also reuse the code. Now, as you're making use of reusable code, it is also going to decrease the time that is being used to modularize the software. Now, modularize in here means breaking down into different components or parts is called as modularization. Now, benefits of this particular model. Now, the few benefits of the particular model is it provides you with a better software design that supports through isolating application business logic from supporting and secondary functions. That is in here, you're clearly drawing a line between the business logic and the different types of functions that are there within the software by encapsulating or isolation. Then the next one is localization of cross-cutting concerns is better handled. Now this localization of cross-cutting concerns, this is done by separating different concerns from each other by making use of modular coding. Now modularization reduces maintenance cost because whichever aspect requires the maintenance, you can directly go in there and you can make changes within that particular department or that particular aspect. It provides tools and software coding techniques. Now, as I told you, software coding techniques, it is one of the, you can use this reusable code. You can make use of reusable code to ensure this modular component supports at the source code level. That is, it is going to provide you with different types of tools. For C++, you've got a different tool. For Java, you have a different tool. For .NET, you've got a different tool. For XML, you've got a different tool. These different tools have got different techniques so that it can ensure the best modular content is being produced. And it promotes the reusability of code used for modularization of the cross-cutting concern. These are the three specialized process model: the component-based development, the formal methods model, and the aspect-oriented. Component-based model, it focuses on reusing the different components, like ready-to-use components. Formal methods model, it focuses on using mathematical formulas for verification purpose. And then the last one is aspect-oriented development model. This technique is used for separating components with their features by providing different tools. The end of the class.